Next, I have f of x is x cubed minus 8x squared plus 37x minus 50. So first, when we're finding all the complex zeros, what we want to do is we need to first find all of the rational zeros. So let's make a list of the possible rational zeros. In this case, q is 1, so I can kind of ignore it because it's going to be every factor of 50. So I have plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, plus or minus 25, plus or minus 50. Gosh, this is a lot of factors. So let's go ahead and test them. If I have f of 1, that's 1 minus 8 plus 37 minus 50. I'm substituting in 1, and 1 squared and cubed and by itself is 1. So I get negative 20. If I have f of negative 1, that gives me negative 1 minus 8 minus 37 minus 50. And I can tell you what, this is definitely not 0. I don't even need to bother to add it up. It's unnecessary math. But what about f of 2? Well, that gives me 2 cubed minus 2 squared plus 37 times 2 minus 50. So I get 8 minus 32 plus 74 equals, minus 50. And that's going to give me a negative 24 plus 74 minus 50, which guess what is 0. Yay! This is 0. So we found one of our possible zeros. So I have when x equals 2, that's a 0. We're going to list all the zeros. So I can go ahead and use synthetic division to see what the remaining quotient would be. So I'm going to clear a little bit of room just right here, I'm thinking. So I have 2, and I want to see how that divides into 1x cubed minus 8x squared plus 37x minus 50. You pull down your first term. 2 times 1 is 2. Negative 8 and 2 is negative 6. 2 times negative 6 is negative 12. 37 and negative 12 is a positive 25. 2 times 25 is 50. Negative 50 and 50 is 0. So now I have f of x is x minus 2, right, because it's x minus our factor k, times x squared minus 6x plus 25. So first, as always, because I don't know that this is going to be complex, I told you it's going to have complex zeros, but you wouldn't know otherwise. I say, okay, what are some factors of 25 that add up to negative 6? Well, there are no factors of 25 that add up to 26, so we need to use the quadratic formula. So a is 1, b is negative 6, c is 25. Now this could just give us rational zeros. It doesn't guarantee that they're complex, but this case they are going to be complex. So x is negative b, which would be a positive 6, plus or minus the square root of b squared minus 4 times a times c all over 2a. So I have x equals 6 plus or minus the square root of 36 minus 100 over 2. X equals 3 plus or minus, sorry, I skipped a step, 6 plus or minus the square root of negative 64 over 2. So I get x is 6 plus or minus 8i over 2, which simplifies to x is 3 plus or minus 8i. So f of x is a polynomial, right? It could have at most 3 rational zeros. Turns out it only has 1 rational zero and 2 complex zeros. This means it only crosses the x-axis once. And those complex zeros, of course, must be conjugates. We can also use zeros to find polynomials of a given degree that satisfy specific conditions. So let's say I have a polynomial and I want to find a polynomial. It's not going to be the only polynomial. There are multiple polynomials who could have these zeros, but I have a given value that when x is 1, y is 3. So that gives us some specifics. So my zeros are negative 1, 2, and 4. So I'm going to take f of x is some constant times x plus 1, remember we changed the sign because it's all x minus k, times x minus 2 and x minus 4. So I know that when x is 1, f of x is 3. So I have 3 is a times 1 plus 1, 1 minus 2, and 1 minus 3. So 3 is a times 2 times negative 1 times a negative 3. So 3 is 6a, so 1/2 is a. Now, how do I figure out what my polynomial is? Well, I'm going to substitute 1/2 in for a and FOIL out. On exams, I'll typically say leave this in factored form, but this one I thought I'd do for you guys. So let's go on another window and switch to a nice and bright color. So I have f of x is our leading coefficient, which we've determined to be 1/2, times x plus 1, times x minus 2, times x minus 4. Now I'm going to FOIL from right to left. I'm going to FOIL first these two, and then I'll go ahead and distribute this and then the 1/2. So that's my steps. So I'm going to have f of x is 1/2 x plus 1. These two FOILed together, I've got x squared, negative 2x, negative 4x, and negative 2x is a negative 6x plus 8. Now I have f of x is 1/2. I'm going to take this x and multiply it by everything. So I've got x cubed minus 6x squared plus 8x. Now I have to distribute this 1. So I've got plus x squared minus 6x plus 8. I combine like terms. I find f of x is 1/2 x cubed minus 5x squared plus 2x plus 8, and I distribute that 1/2. So I have f of x is 1/2 x cubed minus 5/2 x squared plus 2 times 1/2 is just 1x, 8 times 1/2 is 4. So that would be a polynomial that has the zeros -1, 2, and 4, and also has when x is 1, y is 3.